Question number 3 says, let the sum of n, 2n and 3n terms of an AP, n, 2n and 3n terms of an AP be S1, S2 and S3 respectively. Show that this. Okay, for an AP, S1, S2, S3 are the sum of n, 2n and 3n terms of an AP, and we are supposed to prove something, okay. So given S1 is equal to n by 2, 2a plus n minus 1 d. This is what you know. S2 is equal to 2n by 2, 2a plus 2n minus 1 times common difference. S3 is equal to 3n by 2. In the bracket we have 2a plus 3n minus 1 times d. This is what we have. This is given. And we are supposed to prove S3 is equal to 3 times S2 minus S1. This is what we want to prove. Okay. What else? Is there anything else? No, just that. So we can find S2 minus S1 somehow. Let's focus on finding S2 minus S1. S2 minus S1 is equal to what? Or should we say that we can finding basically RHS. We are simplifying RHS, which is equal to 3 times S2 minus S1, which is equal to 3 times in the bracket you have, okay, S2 is 2n by 2, which is n times 2a plus 2n minus 1 d minus, this is a square bracket, okay, this is S2 minus S1 will be n by 2. In the bracket you have 2a plus n minus 1 times d, okay, like this. This is what you have in the RHS. So this will simplify to what? Let's take a look at this. 3 remains as it is. Within the brackets, what do we see? With 2a, let's see the coefficient of 2a. This is n and this is minus n by 2. This is the coefficient of 2a. What about d? The coefficient of d over here is 2n square minus n. 2n square minus n, and the coefficient of d from here will be n by 2 times n, which is n square by 2 with a minus, and minus of minus will become plus n by 2. This is what you get with 2a and d. This 3 is okay, 2a is also okay, n minus n by 2 is n by 2, plus d is okay. 2n square minus n square by 2 will be 3 by 2 n square, minus n plus n by 2 will be, what will that simplify into? Minus n by 2 is what you get in the bracket, right? This is what you get. Do you see that n by 2 from here, n by 2 from here, and n by 2 from here will come out common? So this becomes 3n by 2. In the bracket you have 2a plus, what does this become? N by 2 comes out common, 3n minus 1 remains with d. And do you observe that this whole expression is nothing but this S3 over here? Yes, this is S3. And we started with the RHS. Have we reached the LHS? Yes, we have reached the LHS, and that's the complete proof of this question. Simple analysis? Yes, very simple analysis, not a difficult thing at all. Right? That's all that you need in this. But can you analyze this question from another angle, from a direct perspective, applying some common sense? Do we see? What do we have? This is S2 minus S1. Now what is S2 minus S1 actually equal to? So S2 is sum of from first to 2n terms. S1 is from first to n terms, okay. When you take the difference, you get n plus 1 to 2n terms. That's what you get, right? Okay. And what is S3? S3 is sum of this starting n terms, next n terms, and the next n terms as well. 1, 2, 3 n terms, right? Okay. And do you also know that terms equidistant from middle will be average, will give average equal to this central term, right? From any middle term, if you take two terms equidistant, what do we get? We get this middle term multiplied by 2, right? So now imagine this. This is basically a long series. Instead of n, imagine 30 terms. S3n, 3n, imagine 30 terms. So you have first 10 terms in the first 20 terms and first 30 terms. When you see the RHS, what do we have? We have first 20 minus first 10 is 11 to 20 terms over there, and that is multiplied by 3, right or not? Yes. What is that equal to? That is equal to S3, as the person says. S3 is simply this. First 10, next 20, next 10 and the last 10. The next 10 will be equal, that's not an issue. But what about these two terms? These two terms added together will be equal to twice this center term. Okay, first 10 and the last 10 will be added together and they will be equal to twice the middle 10 terms. That's what you can see from here. Yes, so that's another way of looking at this whole expression, as you can see over here. And this is the general proof that we have discussed in this question. Is that okay? That's true for an arithmetic progression, and yes, we have analyzed this complete question thoroughly.